All right. I hope everyone's doing okay. This is the video for Tuesday, April the 14th, and it goes along with the 13th worksheet in Algebra 1. Hope everyone's doing well today. It's been freezing cold and windy outside, so looking forward to warm weather returning. Today we're going to talk about how to calculate the total cost of an item. Okay, so let's think about a subscription or something like that. The example used in your worksheet is based on paving roads in Yavapai County, and it's not necessarily a cost problem, but it functions exactly like a cost problem. So I thought we would use a cost problem as an example to get started. So let me give you an example of what I'm talking about. Let's say that there's this really cool app that does whatever it was that I needed to do, music app, whatever. And it has an initial sign up fee, right? Let's say it's going to cost me $20 to download the app. And then after that, I have to pay, let's say, $5 a month. Okay, so the initial cost can also be called my fixed cost. It's fixed because no matter how many months I keep the subscription, whether it's just 1 month or whether it's 60 months, my fixed costs are exactly the same. Okay, you see how over time my total purchase becomes more reasonable because my fixed costs are my initial startup costs. Think of those as like, you know, your costs to get into something, right? So if it costs me $20 to buy the app and then $4 a month to continue my subscription, well, what I have is I've got my initial cost and then I have my repeating cost. Okay, so my repeating cost is how much I get charged on a repeating basis, right? So I may be charged, in the example I'm using here of the app, I'm charged every month. So every month I get a bill, right? Some repeating costs are annual costs, so you just get charged once a year. And oftentimes the variable we use to talk about how many units of time, whether it's months or years or weeks or whatever it is the letter N. N because it stands for numbers. So when you're taking the SAT and it says N, you're usually thinking it means some number that it literally means some random number. Okay, so if I'm gonna calculate my cost. Let's calculate my cost for this app. I have a fixed or initial cost of $20, and then I have a repeating cost of $4 a month. N is going to be the number of months, right? So if I want to say, well, how much is it going to cost for me to have a subscription for N number of months, or let's just randomly choose 6 months, my cost would be, my total cost is going to be my initial cost plus my repeating cost times the number of times that it's repeated. Okay, so let's use this example of the app. My total cost, which I'm going to calculate, I'm going to call a big capital C, equals my initial cost, which we said was $20, plus my repeating cost, which we said was $4, times N, and N is the number of times it's repeated. So if it's 6 months, I'm going to say times 6. Okay, so my total cost is going to be $20 plus $24, or my total cost is going to be $44. All right, well, let's say that I keep this particular app not just for 6 months, but let's say I'm gonna do it for an entire year. Okay, so let's see how this works out. If I'm charged on a monthly basis, okay, in other words, N is the number of times that it's repeated, the cost is repeated, that would be 12 months. So my initial cost is still $20 plus my repeating costs times the number of times it's repeated is $48. So now my total cost for a whole year is $68. Okay, if you can do some quick mental math, you notice that it costs less per month to have it for a whole year compared to just having it for 6 months. And why is that? Because if you're calculating your average cost per month, you're dividing this, your initial cost, by however many months that you're using. So if I'm thinking my cost per month actually gets closer and closer to this $4 the longer I have. In fact, if I kept this for let's say a full 5 years, right? If I went to 5 years, which is 60 months, my initial costs are still $20. Well, that $20 doesn't make a whole lot of difference in my price now because I've spread my $20, my initial cost, over 60 months. So let's look at what this is. This is $20 plus $240. So I can see, yeah, this is going to be more money to have the app for 5 years, but my average monthly cost is really coming down because I'm spreading my initial cost out over this amount. So $260 becomes my total cost for 5 years. So this principle can be applied then if we're talking about things that aren't necessarily cost, but I thought it'd be easier to introduce it to you as a cost concept. Let's look at today's example from our homework. Is rather than the concept of cost, we're just going to call it an amount. My initial amount and my repeating amount. Okay? So here's the way that the problem works. It's based on Yavapai County, which once upon a time was the largest county in America. In fact, as a county, it was larger than several northeastern states, bigger than Massachusetts, bigger than Delaware or Connecticut. And it's a county that I lived in twice growing up. It's a massive, massive county, but there aren't that many people there. So we start off with the assumption that in 2014, Yavapai County had 783 miles of road, okay? So we start off with an assumption that in 2014, we had 783 miles of paved roads in the county. And then each year after that, we're going to assume that they're going to create or build and pave an additional 8 miles, okay? So your questions in your homework are going to have to do with this concept. So if we start off with 783 miles, and this is 2014, well, in 2015, they add 8 more miles. Well, you can do that in your head, right? You can look up there and you could say, oh, well, in 2015, they add 791 miles, okay? But oftentimes when we're using this kind of math, we're using it more predictively, okay? So we're not talking about how many total miles do they have in 2 or 3 years, even though you can still use this particular formula to calculate that. A lot of times we'll be calculating, we'll say, okay, well, in 30 years, how many miles are they going to have? Do I want to add 8 plus 8 plus 8 30 times? No, I'm going to come up with an algebraic expression, and it's going to communicate where I would be in any given number of years. Okay, in this particular case, because we're talking about miles per year, n is going to be the number of years. And what is n? It's just how many of your years you want to check, okay? So let's say, well, how many miles are they going to have in 10 years? Well, let's see that. If we started off in 2014 with 783 miles, and we want to see, well, in 10 years, how many miles will they have paved? here's what we're going to have. Our total amount is going to equal our initial amount plus our repeating amount times how many times we're repeating it. Okay, in this particular example, 10 times, because we want to know where they're going to be in 10 years. So what is the total amount? Okay, T, I'm going to call that capital T, is going to equal 783 plus how many miles are they putting in every year? 8 times N. What is N? In this particular example, it's 10, because we want to know where they're going to be in 2024. That would be 10 years after our initial date. If we started in 2014 and we want to check for 10 years later, that'd be 2024. So now what I need to do is I'm going to say T equals 783 plus 80, or T equals 863 miles. Okay? If N equals 10, then our total number of miles is 863. And this is our formula right here. Total amount plus our initial. This is a plus the repeating amount times the number of times it's repeated. Okay? So what if I were to tell you that you're not going to be given, to a different example. I like to give a free one away for those who are faithful to watch the video. What if I don't know how many years it is, but they tell me, well, how many years, what year is it going to be in which they have 1,000 miles? If they continue adding 8 miles every year, and of course they're repairing the roads they have, so you don't have any going out of service or anything like that. We're just adding. Then what I'm going to do is I need to figure out what is my number of years, right? So if I don't know my number of years, guess what I do know? I know what my total amount is. And the question is, well, in what year, how many years is it going to take to get them to 1,000? Okay. In what year, if they started with 783 in 2014, in what year will they say, we've got 1,000 paved miles? Well, this is very simple. We're going to solve for N, okay? So in this particular case, I've got 1,000 equals 783 plus 8 times N, and I don't know what N is. I don't know how many years that is. So I'm going to start off by solving for N. The easiest thing to do would be to get rid of the 783. So I'm going to subtract 783 from both sides. And if I subtract 783 from this side, it's just going to get rid of that number. If I subtract 783 from this side, it's going to give me 217. Okay? Double check my math really quickly. It is equals 8 times N. Okay, now I'm going to solve for N. I've got 217 equals 8 times N. I'm going to divide both sides by 8. Now, here's the deal. If I want to know what year it's in, I can't give a fractional year. For example, if I divide both sides by 8, this number is not going to give me a number that's equally divisible by 8. In other words, I need to know a whole number, so I'm going to have to round to the next whole number. Okay, so if I do this really quickly, N is going to equal, and notice that I'm putting my N over here because it doesn't matter which side of the equal sign it's on. I always like when I'm solving, I like to write it like I'm going to say it. Variable equals answer. Okay, and I'll do this. I'm filming this well after midnight. I don't trust my math. 217 divided by 8 equals 27.125. So it's going to take them 27 and an eighth of a year. So what year is it going to be? I'm just going to go ahead and call that 28 years. Okay. So N equals 27 and an eighth. I'm going to make that 28 years. Okay. But if the question was, what year will that be? Well, the way I have to calculate that is if I started out in 2014 and I add now 28 years, that means in the year 2042, in the year 2042. You know, I'm going to tell you something. Once upon a time, 2042 sounded like, I don't know, space alien kind of years, like weird amounts of years. It's only 22 years from now. And 22 years, that is not, I can tell you where I was 22 years ago and how long ago 22 years ago was, and it wasn't that long ago. Just like, it just goes just like that. So you think about it, 2042 is not that long down the road. Anyhow, there's a couple other problems just solving for the variable, including some fractions. So it's just a review of things that we've done before. Call, text if you need me. Peace out. Power to the people. Math rocks. You rule.